Hello and welcome to the first part of lesson 12.5. Okay, today we're going to look at independent and dependent events. And today we're going to specifically concentrate on independent events. In the part 2 video, we'll look at the dependent events. But right now, an independent event is an event in which one event does not affect the other. So what that means is if we're flipping a coin or rolling a dice. So if I flip a coin once and I get heads, and I flip that same coin again, I can still have the same probability of getting a heads or a tails as I did on the first flip because they are independent events. Okay, if I roll a dice, okay, and keep in mind it's just one dice. If I roll a dice and let's say I get a number 2 to pop up and I go to roll that again, I can still get another number 2 to pop up, or I could get any other number 1 through 6 to come up. So whatever I rolled the first time does not have any impact on what I rolled the second time, because these are what we call independent events. They do not affect each other. When calculating the probability of independent events, okay, again, these are events that do not rely or affect the probability of another event occurring. So it says for two independent events, A and B, the probability of both events occurring is the product of the probabilities of each. Okay, so if we go to that heads and tail coin toss, okay, we know that if I'm going to put toss number 1 and toss number 2. Okay, so if I go and I flip a coin the first time, we know that we can either get a heads or a tail. So this tells me I have a probability of 1 out of 2 different possibilities. For my second coin toss, I can still get a heads or a tails, which tells me I have a 1 out of 2 probability for my second coin toss. So if I want to find the probability of both events occurring, I'm going to take, based on my definition right here, it says the probability of A happening, which is toss 1, then the probability of B, or toss 2, occurring. I'm going to take and multiply those two probabilities together. So I have 1/2 times 1/2, which gives me 1/4. So this right here is my probability of tossing something like, say, maybe 2 tails or something like that. So with this information, let's look at example 1. Example 1 says you roll a number cube, which is a dice, then you roll it again. What is the probability that you get 2 on the first roll and a number greater than 4 on the second roll? So what we have to do is we have to look at the independent probabilities first. So for our first roll, we want to roll the number 2. We know that we have one number 2 on a 6-sided die out of 6 total possibilities. So when I go and I look at my second roll says you want to get a number greater than 4 on this. So a number greater than 4 is just going to give me the numbers 5 and 6. It doesn't say greater than or equal to, it says greater than 4. So here I have 2 possibilities out of a 6 total numbers that are on that dice. So in this case, if I want to find the probability that I will roll a number 2 and a number greater than 4 on the second roll, I'm going to take these two numbers and multiply them together. So I have 1/6 times 2/6. Remember, with multiplication, we multiply straight across. So 1 times 2 will give me 2. 6 times 6 gives me 36. And if I reduce my fraction down, I end up with 1/18. So in order to roll a 2 on the first try and a number greater than 4 on the second try, that tells me my probability is 1 out of 18. For example number 2, it says you toss a coin twice. Find the probability of getting 2 heads. So I'm going to look at toss 1 and toss number 2. So I know the first time I toss this coin, I have a 1 chance, because I can either get a heads or a tails, and I know that there's only 1 heads out of 2 possible choices. For toss number 2, there's also only 1 heads out of 2 possible choices. So if I multiply these two together, I end up with 1 times 1 in the top, which is 1, and 2 times 2 on the bottom is 4. So I'm going to end up with a 1 out of 4 chances of getting both tosses to be a heads. Okay, and now for our final example. Example 3 says, under the best conditions, a wild bluebonnet seed has a 20% probability of growing. If you select 2 seeds at random, what is the probability that both will grow under the best conditions? So we know, or we're given, that the best conditions for a seed to grow is a 20% probability. Well, remember, 20% written as a decimal would become 0.2, and you can make it 0.20 if you want, because you have to move that decimal place 2 places to the left. So we know that the probability of 1 seed growing, so I'm going to say 1 seed, and then we'll have the second seed. Okay, so the probability of 1 seed growing is going to be 0.2, and the probability of another seed, or the second seed growing, is also going to be 0.2. So if we multiply these two numbers together, we're going to get 0.04. So as a percentage, if we switch this around, remember now I have to move that decimal place 2 places to the right. So this tells me that I have a 4% chance of grabbing 2 seeds that will grow under the best conditions. So this is going to conclude the part 1 video. If you have any questions, please send me an email. Thanks and have a great day.